Hello everyone, welcome to Swiflearn live classes. How are you? I hope everybody's fine and safe, right? Welcome back to the Harneet Ma'am class, and today's topic is to understand quadrilaterals. So before going directly to the topic, let us understand what the company Swiflearn is and what do we do. All right, so Swiflearn is a company in which we teach students from the grade 3rd to 10th. That's right, from the grade 3rd to 10th, all the students we teach them. How do we teach is the process that is 100% live and interactive class. So what does we mean by this is that each and every class is given directly to you. There is no pre-recorded classes. There's nothing that you're coming later and you cannot ask us. We are there present live in front of you on one side of the computer or the laptop and you are on the other side, right? So we are communicating with you directly. So whatever the problem is, we can directly solve it there and then. The second most important feature, which is that we have a class in which they give the maximum number of students that can be enrolled in one particular class is 6. That means we will not have more than 6 students in a group. So by this, we are able to concentrate more and understand where are you lacking. So what is your problem? Like what concept you have not understood properly, we can concentrate over it and we can solve it. See, in a school, it's such a big class, around 30, 35 students. So practically for a teacher to stay there for an hour, deliver that topic and solve each and every doubt of each and every student is quite a difficult task. Right. In the process of doing it to her best of her ability, still they are not able to solve some of the questions. And due to which the students have a problem with that subject. They think that this subject is very tough. They're not understanding. But the thing is, that is not the problem. Understanding, they are understanding the things, but they are not able to clarify what is the difference. What they have to do in this particular type of questions and what they have to do in the other questions. So what is the difference? To analyze that difference, we are there to teach you. All right, so the 6-student batch is a very good option in which we can give you a personalized attention and each and every topic and the concern is taken under consideration. Okay. And we also have an academic mentor team to track and work on students' progress. So yes, whatever you're doing in the classwork, when we are teaching you there, whatever the work we give you or the assignments that we give you, you solve that, right? When you're solving it, we get to know how are you performing. All right. So with this also, we are able to know where do you stand. So it is an academic mentor team that tracks your work and the process, what you are doing. All right. Now, the next thing is that we cover syllabus as per school exam schedules and also handle custom requests. So what do we mean by this is that if you think that a particular topic, you are very sure that you know it, you don't want to study from us. Instead of that, you want some other topic that is not in the course or curriculum, but still you want us to explain you and explore the world around. So we are there to help you with that also. We can deliver that concept to you easily, and we also provide customized requests. So we give you assignments and we give you practice sessions on the topic which you want according to you and your preferences. Okay, so all these finds makes us the India's most sincere learning destination of the classes 3rd to 10th. Yes, right. We call it sincere because we take a notice of each and every point. We keep a track of your progress and we are taking a feedback regularly, and the way you want, we give in a better form. Okay, so we are improving each and every day with you all. So even you are improving yourself and we are improving with what you want, right? Okay, so our key features are that there is a detailed progress report that I already mentioned that you can see like a statistics graph in your profile when you log in. So will you know where do you stand right now? And after enrolling yourself with us and taking the future classes, how the graph is moving. Are you going up or not? So we take that very seriously. The second thing is that there is Swiflearn Academic Test Series. So we call it SATs. What is it? That on every Sundays, we keep a SAT exam on an international level. So what you have to do is you have to enroll yourself, give those exams, and actually see where do you stand on an international level. So that is what the main point is, right? At last, in the end of the day, you have to be in a competitive world. So each and everyone is taking their own space to understand, but they all land up on the space, same standard, same space, whereas the competition level, right? So this SAT exams makes you more eligible and understand how the concepts are given, how the competitive questions are asked. That gives you a clarity. All right, for the future exams, so these stats are very important, we would say. The third is that we give you unlimited practice tests. So there is no limits, no numbers. We keep on giving you unlimited practice tests so that you can keep on practicing. You will understand the concept more wisely, and we all follow that practice makes a man perfect, right? So even if you are practicing, you are getting perfection. So final in the exam, in the school's exams or in the board exams, you are able to understand the concept, and those questions you have already practiced so much that you know how to follow the steps. All right, so I think this point is very important. The last and the most important point is subjective test for school exams. See, we all know that the school exams are subjective. So you have to write each and every step. It's not a multi-choice questions that you have to just click on the point and you don't know the direct answer. That is not what the teacher asks us in the school exams, right? So what do? We give you a subjective test in which you have to give us all the things, all step by step steps are there, and you have to tell us that, okay? You have to upload that picture on the profile and we get to know how are you solving those questions. So in case you're giving a wrong answer but your steps are right, so we know exactly what mistake have you done, and we can just concentrate on that point instead of giving the whole topic again. That would be a boring lecture, right? Understanding the thing which you already know, but instead we concentrate on what is the point at which you are lacking. So that's why these are the key features that make us apart from all the other institutes which are giving the classes online. Okay, I hope you are taking it seriously and you understand what we are teaching. So if you like what we are doing, so kindly subscribe to our channel, the YouTube channel named Swiflearn, and press on the bell icon so that you don't miss any update what we are here to teach you, right? Hope you are doing it. Okay, I'll give you a second. Do it right now. All right, great. So let's start today's topic. What's the topic for the day? Today's topic is to understand quadrilaterals. So it will be the introduction, and we will also study what are polygons. So what are quadrilaterals? What are polygons? Their introduction. This all we will cover in today's class. So do you all know what are these things? So the objective for today's class are that introduction of plane surface and plane curves. So we'll do what are plane surfaces, what are plane curves. We'll understand what is a polygon and how are they classified, what are the different types of polygons. We'll also try to understand what is a diagonal. What do we mean by a diagonal? And then we have 4 types of polygons. One is convex, concave. The other 2 are regular and irregular polygons. So these are the topic which we will cover in today's class. All right. So let's go. Good to go? Gives a thumbs up. All right, let's start. Before that, I'll give you a simple question. Can you tell me the names of this figure? So let's go one by one. So what is the name of this figure? What is it? Is there anyone there with me? Can you tell me which figure is this? What is the name of this? Yes, this figure is known as a rectangle. Okay. How about this one? What is this known as? It is a triangle. That's right. How about this one? It's whole round, round, round. We call it a circle. Pretty good. How about this? It looks like four sides, so it will be a rectangle. But no, we know that the opposite sides are equal in length. So I can see this one is a longer one, this one is a shorter one. So we can't say it's a rectangle. So what is it? It is a quadrilateral, right? Great. So let's see. Are you able to get the answers? That's right. We got the right answers. The rectangle, triangle, circle, and quadrilaterals. All right. So let's go about it. So before understanding what is a polygon, how to proceed, let us understand what are plane surfaces. So what exactly are plane surfaces? The flat surfaces are called the plane surfaces. See, a register. This is flat. Can you see that? It's flat. So something which is flat, we call it plane surface. Pretty easy. Like a paper or the table mat on which the table surface or a textbook. So it is very plain, right? It's straight. So we call it a flat surface, which is straight and plain. We call it a plane surface. Pretty easy. Yeah. How about what is a plane curve? So for plane curve, you need to understand what is it. See, on a page, on a sheet of paper, you put some points and you join it. It can be in any form, right? Is it any hard and fast rule that the points have to be in this particular way? No, right? I said any point. So it can be like this. Now I need to join these points. Let's join. Okay, now it's going here. It's going here. Okay, so what I have done, we have just joined the number of points without lifting the pencil. So we are not picking up the pencil from one point and then putting it to the other point. Now I'm not starting from here again. This is not the logic. So we have to just keep on drawing without moving the pencil or picking it up. So this I can say these are known as a plane curve. So what is happening is we are actually moving it. Can you see there is a curve? There is a bend at this point. There is a bend at this point. At all the corners, can you see it? So this is not a plane surface. This is known as a plane curve, where it is moving. We are getting a different direction. So from here, we are changing the direction. Earlier, we were going, I would say that, see, earlier we were going in this direction. But after this point, we change the direction. So the moment we change it, the direction, we call it a curve. Similarly, when we are going it here, we thought of changing the direction going it here. Then we go down, then we go up from this point. So this point from which we are taking a change in direction, these figures are known as plane curve figures. All right. All right. So now, what exactly do we mean with this? Now, these are some plane figures, plane curves. You have to tell me which type of curves are these. We have already done it. Okay, now these are the four figures and these are the four options. You need to tell me. Okay, let's go one by one. What figure is this? Is it a simple closed curve? Yeah, it is a curve, but it is a closed curve. Is it closed? Is it somewhere by which we cannot enter inside? No, it is not closed. Can you see that? We can enter from here, right? So when it is not closed, we call it simple. No, it's not closed. We will not take this option. Moving on to the next one, it says that closed curve surface that is not simple. So is it a closed curve? Is it a closed curve? No, it is not. So we'll say it is not this option. It is not a closed curve. That is not simple. All right. Moving on to the third, it says it's simple curve but not closed. Yes, this is simple curve figure. Can you see that? It is a curved. It is simply curved, but it is not closed. It is opened. So yes, we can say that this is the right option with this one. So it is a simple curved figure that is not closed. How about this one? How do you feel? Is it simple curved? No, we said simply means it will not interlock by each other, right? So it is getting overlapped, due to which we'll say it is not a close. So we'll say it is not a simple curve. It is not a simple curved figure. How about this one? Pretty easy. It's all closed inside like a circle. So what will it say? It will say it is a simple closed curve. It's pretty easy. How about this one? What do we mean by this? Is it a closed curve? Yes, it is. I cannot get inside this figure, nor do I can get inside this triangle. And that is not simple. See, something which is called simple, it is that it's going in the simple way. It's not meeting at a point. Here, when the objects or the curves were meeting, we call it, it was not simple. Can you see it? We call it not simple curve because they are not meeting. They are meeting at a point. It's not simply different directions. Instead, they are meeting and interacting. That makes it a little complicated. So we don't call it simple. Same way here, when we see that they are meeting at this point. Can you see that? That what is happening? They are meeting at this point. So we'll call it, they are not simple curved figures. All right. What is it? They are not simple curved figures. All right, let's see. Have we done it properly? That's right. Great. Okay, so let's start. What is polygons? What do we mean by a polygon? See, we have already discussed what are simple figures. We know what are closed figures. We know what are curves, right? But when we bring all these things together, it should be simple, it should be closed, and it should be curved with only lines. There should be only line segments. Then we call it a polygon. Okay? If I say, see, there is a difference between this. Simple means they should not interact. Okay, it should be closed and it should be curved. If I say this, I can think of a circle, right? It is simple, it's not interacting, it is closed also, and it is curved also, right? But why am I saying only line segments? Because I don't want a proper curved figure. I want only a figure with the line segments. So this can be a line segment, 1, 2, 3, 4, 5, 6. So it is a polygon which has 6 line segments, AB, BC, CD, DE, EF, and FA. So this is the reason why we call it a polygon. So these are the points that you have to keep in mind. All right. So what are the points that you have to keep in mind? That it has to be a simple closed figure and it has to be only with the line segments. Can you get it? So it only has to be with the line segments. Clear? Okay. Let's see what's next. See, these curves that are polygons, we can have it in example with me. It's going a line segment. All are the line segments and they are closed figures. We cannot get inside it and they are curved ones. So they're simple curve. They are not meeting at a point or making an interaction. So that's why when these types of figures, we call it a polygon. Whereas these one are not called a polygon. Why? Now the reason you know it very well. Yes. The reason is that the curves, they are not a polygon because they do not meet at a point. That is what we say. We say that they are closed and simple. Simple means that they don't have any interaction. But here we can see that they are meeting at a point. So we will not call it a polygon. How about this one? See, it's not closed, it's open. So the moment it's open, we know it that a polygon is closed figure. So we'll say, no, this is not a polygon because it is not a closed figure. The reason for this, it is not a simple closed figure. Clear with this? All right. Classification of polygons. Can we classify polygons according to the number of sides or vertices they have? So see, we know now what are polygons. They are made with the line segments. So we have classified these polygons based on their line segments. The more the number of lines they are, like of a polygons, the different name we give to them. So the basic polygons, the simplest one will need how many line segments? Can you tell me? Yeah, which will be the basic line segment needed for a polygon to be formed. Can it be made by one line segment? No, right? How about let's do it two? Let me get it here. Is it a polygon? No, because it's not closed, right? So a basic, the number one, the minimum requirement is for 3 line segments. So we need 3 line segments to build the first polygon. And that first polygons with the 3 line segments, we call it a, what do we call it? We call it a triangle, right? If a number of sides or the vertices are 3, the polygon is known as a triangle. Can you see that? So this is the first polygon that can be made. We cannot make a polygon with 2 or 1 line segments. So minimum we need 3 line segments. How about when we have 4 line segments? 4 line segments means 4 sides or 4 vertices, we can say that, okay? So what do we call it? We call it a quadrilateral. So quadri stands for 4. Just remember, quadri means 4. So we call it quadrilateral. How about 5 sides? Can we see? 1, 2, 3, 4, 5. So there are 5 sides, or we can say there are 5 vertices. Can we say it? A, B, C, D, E. So there are 5 vertices. Vertex A, vertex B, C, D, E. So 5 vertices or 5 sides, we call that figure known as a pentagon. So penta stands for 5. We'll remember like this. Okay, penta stands for 5. How about a hexagon? Hexa stands for 6. So we'll see there are 6 sides. 1, 2, 3, 4, 5, 6. Clear? So this is the way we give different names depending on the number of sides we have, or we can say the vertices. The 7 sides, we call it heptagon. So hepta stands for 7. How about, have you seen an octopus? Octopus has 8 legs. So octo comes from that octopus. We call it octagon. So 8 stands for octagon. 9 stands for nonagon. And 10 stands for decagon. How do we say deca? See, we say it's mean a decade. Decade stands for 10 years, right? So from decade, we call it deca. So deca stands for 10. All right, great. Now, moving on, see, these are the different types we have studied: a triangle, a quadrilateral, a hexagon, an octagon, a pentagon, a nonagon, or decagon. Right? Or a heptagon as well. So these are the different types of polygons that we have studied so far. There are n number of polygons. You can make any number of polygons you want. The number of lengths would start becoming smaller and smaller. And you can make it a bigger quadrilateral, a bigger polygons with the large number of sides. That is not a problem. It's up to you. So we are just learning the names till 10. All right. Now let's move on. What is a diagonal? What do I mean by a diagonal? See, we know that a rectangle PQRS, it's a quadrilateral. We know that. We can say it a rectangle as well. That's not a problem. Okay. But what is a diagonal? A diagonal is a line segment that connects 2 non-consecutive vertices of a polygon. What do I mean by non-consecutive vertices? What do I mean by this? I mean, see, if I talk about a vertex S, then R and P are adjacent to each other. Like S, the next is R, from S, the next is P. But which is the vertex which is far, which is not close to S? That takes a longer distance, or which is not joined with that. So if I see from this direction, I can go here or here. What do I get? I get P and R on the respective directions. But what is happening is I am leaving the Q outside. So I'm not having it with them joined together. So the vertex, which is on a different place, and we have to go from here to it, and it is not joined together. It's not next to it. It's not adjacent. So that is known as non-consecutive vertices, which are not joined together. So in this case, we'll say S and Q is a, SQ is a diagonal. For PQ, PR will be the diagonal, and for SR side, SQ will be the diagonal. We can say it for SP side as well. SQ will be the diagonal. Clear with this? How is it with the P? Same. See, from P will go S or PQ, whereas R is on the other side. So I have to cross the bridge. We can think it like that. So we have to cross the bridge to reach to the other one. We can directly not go to the left direction or to the right one. All right. So when you need a bridge to go it somewhere else, we call it a diagonal. You can think it like that also. All right. Moving on to the next one. In this case, let's say I'll give you one figure. What exactly the figure is, it's like this. Oops, I made a little wrong. I'll just draw it properly once again. Okay, let's make it like this. It is somewhat like this. Can you see that? Okay, let's say this one. It looks somewhat similar. So it's N, this is O, this is M, and this is L. That is right. Okay, let's look for the diagonals here. So how will I know what are the diagonals? From M, if I have to go, I can go towards O, or I can go towards N. Is there any way I can go towards L? It's coming directly from here. Can you see that? Straight. So this thing in which we are leaving one vertex out, we call it ML as a diagonal. Now let's look at the point, let's say N. At N point, if I have to go, I can go towards M, I can go towards L. But I have to go towards O. So taking a bridge, so I'm making this dots. So I'll say ON is a diagonal. Clear? So these is what we call a diagonal. So for MN, ML is a diagonal, and similarly, ON is a diagonal for this figure. But have you noticed the difference between what we did before and what we are doing it right now? See, ML has a diagonal, but that is outside the figure, right? It is not coming in the figure that we draw. Can you see that? We draw the figure in green color, whereas the diagonal is coming outside the figure, whereas ON is coming inside the figure. So these things makes the figures different. How and how are we naming it? That we'll study in the next slide. See, what is happening now is, with the help of these diagonals, first of all, let's see, and I'll test you how many diagonals are there in this. Can you count the number of diagonals? Okay, before that, start naming the vertices. It's A, B, C, D, E, F. Okay, we can start from any vertex I want. So let's take E as the first vertex, and I'll draw a diagonal. Which are the diagonals from here? From E point, the first diagonal we can say is EA, because from E I can go towards F, I can go towards T, but whereas A, B, and C are far apart, so I need a bridge. So I'll get EA, EB, and EC as a diagonal from the E point. Let's move with the D point. Similarly, from D, E is the near one, C I have a way to go. Whereas for F, A, and B, I need a bridge. So I have to go in some other way. So I'll say that DF, DA, and DB are diagonals. So from these 2 points, I've got 6 diagonals so far. Let's move to point C. All right, from C, I know that I can go to CB, CD, whereas CE, CF, and CA are the diagonals. CE or EC mean the same thing, right? So I'm left with CF and CA. All right, let's move to the B point now. From B, the diagonal will be BD, BE, BF. So BD, B and D. Where are they? We have that. BD. Yeah, here it is. DB or BD stands same thing. So I have that diagonal with me. How about BE? EB, BE means the same thing. So I'll just add BF. Just one diagonal is left. Let's move to the diagonals at point A. So AE, AD, AE, AE, AD, AC. So I got all the diagonals. How about F? So from F, I'll have FB, FC, FD. So FB, FC, FD. So how many diagonals do I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 diagonals so far. Clear? Let's see. Are we able to find that? Yes, there are 9 diagonals. Yes, Bacha, Tanya ma'am is taking the classes for 10th grade. We know that, and that will be scheduled. So that will come on the systems. For that, are you subscribing to the channel? Are you clicking on the bell icon? The moment you do that, you will get the notification in advance that we have been scheduling a class there. So every day, a day before we schedule each and every class, you can go through this or the YouTube channel. You can see what are the upcoming lectures. So we know that Tanya ma'am, yours favorite. Great. Happy to hear that you're waiting for her. But I'm very pretty sure that she'll have the classes in the near future. All right. All right. How many diagonals does each one of them have? So how many diagonals do a triangle have? See, a triangle does not have any diagonal. Why? Why do we say? The reason is that already there are 3 sides of a triangle. Can you see that? It's A, B, and C. So from A, if I have to go, I can go to C and B, and I don't have any other vertex. So when I don't have any other vertex to go, where will I go? I don't have any other destination to go. Right. So when you don't have any other destination, that means that you don't have any diagonal in this triangle. All right. Moving on to the next one. It says, now I'll give you a formula that is how do we calculate a diagonal. So how is a formula that tells us to know the number of diagonals in an instant. See what we did for that picture, we had to calculate the diagonals. We had to count that. Instead of counting it, and if suppose I missed anyone, that may be an error for me. So what have we done? We have derived a diagonal formula that says n bracket n minus 3 divided by 2, where n stands for number of diagonals or number of sides of the figure. If I say a triangle has how many sides? So in this, n is equals to 3. So that comes out to be 3 bracket 3 minus 3 upon 2. So when I say 3 minus 3, that becomes 0. That means I have 0 diagonals. Easy. Let's say if a figure which has the number of sides, suppose say 6. So I know n is equals to 6. That comes out as 6 bracket 6 minus 3 upon 2. 6 minus 3, that comes out to be 3 by 2. Now, when I divide 6 by 3, what happens? 6 by 3, it comes out to be 6 by 2, it comes out to be 3, and 3 into 3 is 9, right? So by this, we were able to calculate that the picture has how many diagonals? 9 diagonals. All right. I hope now you can understand how are we doing it. It is pretty easy. Just remember the formula, that is n bracket n minus 1. It's okay, Mohit. Happy to see you back. Hope you understand today's topic. If not, kindly catch up and go back to the video after we finish the classes, okay? All right. I'll still try to catch up with you and you can understand what's happening. Okay. So just remember that number of diagonals, we need this formula n bracket n minus 3, where n stands for the number of sides of a quadrilateral or a polygon. Depending, we have given the names. Quadrilateral means 4, polygons means on the whole part where different categories are there. All right. Let's do another topic, that is an internal and external of the curved shapes. So what is an internal one? Something which is inside, we call it internal. Something which is outside, we call it external. Pretty easy, right? So internal means everything the figure has, it has inside it. So that's why we call it an internal closed curves. If you're talking about the inside of the cloud. Whereas when we are talking about the outside of the cloud, that means it is an external closed curve, which is outside. Clear? So these are the two ways we are talking. When you're talking of internal, that means inside the cloud. When we are talking external, that means outside the cloud. Why are we talking internal and external is, see, these are the ways we can describe what is an convex and what is an concave polygons. We have seen that the diagonal that in the figures 2 that we discussed before, in the first figure, all the diagonals were coming inside the closed figure. Whereas in the second one diagonal was inside and the other one was outside. Like MN was outside and ON was inside. So when we say that polygons which have no portions of their diagonals in the externals, so every diagonal is inside. So let me draw a diagonal first. So one diagonal from here would be this one. One will be this. How about this one? This. From here, we can say we have one more diagonal here. From here, we have all this side is left, right? So these are the diagonals, and when we draw all the diagonals, they are inside. So nothing is coming outside the figure. So when this is happening, we said it is convex polygon. What do we call it? Convex. Easier way is, see, convex has EX at the end. That means it should not be external. Okay? Not. It's saying it's no external. So no, from here we can say it. It says no external. Convex. So convex means everything inside, all the diagonals inside that are called the polygons. That is a convex polygon. Whereas when I say that a diagonal can lie outside, it can come outside, we call it an concave. See this figure in which we had drawn the diagonal like this, right? From this, we had drawn this diagonal. So this diagonal is outside the main figure that was given to us. So when outside the main figure, we call it that the diagonal is outside. We call it is a concave polygon. It is an example of a concave polygon. Easy now? Clear? All right, let's move on to the next, regular and irregular polygons. Now, what are irregular and what are irregular? What do I mean by regular? That keeps on happening at the same level. We keep on doing the same thing again and again, right? So regular means a regular polygon which has an equiangle. So all the angles are equal. We are doing the same thing all over. They are equilateral. So all are of same length. The line segment, the line or the length of the sides are same. Then we call it a regular polygon. A square that has all the sides are equal and all the angles are equal. How? If I draw a square, what does that mean? It means that it has 4 sides and all the sides are equal and it has all the angles are 90 degrees. So when that happens, we call it a regular polygon. All right. Now, can you tell me, can we say a rectangle is a regular polygon or not? Okay, let me get an answer. Okay. Now, can you tell me that this is a rectangle? It's a regular polygon or not? Yeah, it is a quite easy one. Okay. Mohit, can you? Yeah, you can ask the question if you want. I'm there to help you. And till the time Mohit is asking me a question, can you all tell me, is it a? My name is Harneet, Mohit. It's okay. I'm the Harneet ma'am there. Yeah, it is a regular polygon. Will you say a rectangle is a regular polygon? All the angles are equal. That's right. But how about the sides? Are all the sides equal? Are all the four sides equal? No. So we say a regular polygon is where all the angles are equal and all the sides are equal. Whereas in rectangle, only the opposite sides are equal. In that case, we'll say that it is not a regular polygon. Surely a rectangle measures the same measurement, that is 90 degrees, but it's not equilateral. The all sides are not equal. So that's why it's not a regular polygon. Clear? So we call it an irregular polygon. Irregular polygons means that any polygon that have sides of any length or any measurement. So it can be any length, any measurement. We can make it anything we want. We call it an irregular polygon. So a rectangle is an example of a irregular polygon because the sides are not equal. All right. So now moving on to the new concept that says the sum property. Angle sum property. What are angle sum property? Till now, we all know what are angles, right? So angle sum property is measuring the sum of three angles of a triangle. A sum of three angles of a triangle is 180 degree. Angle triangle ABCD. So if I add angle A with angle B and angle C, the sum will come out to be 180 degree. All right. Now, moving with this in a quadrilateral, the property of the sum property of quadrilateral is the sum of all the angles, angle A plus angle B plus angle C plus angle D would come out to be 360 degrees. Now, how will you say? Ma'am, why is it different? See, it is different because we have added one more side. Can you see that? In a triangle, when there were three sides, the sum was equal to 180 degree. Now in a quadrilateral, there are four sides and the sum is equals to 360 degree. How about if I say it is a pentagon, it's five sides, then its sum will be equal to what? It will be different. It will not 180, it will not 360. What will it be? So to know that, we have a formula by which we are easily can calculate. So sum is equals to number of sides minus 2, and then we multiply it by 180 degree. Let's see, have we done so far? How? If I say the quadrilateral for 4, let's see, it's 4 minus 2 into 180 degree. So that times 2 into 180 degree, that comes out to be 360 degree. Perfect. Yeah, for pentagon, it will be 720 degree. That's right. Just or other ways, keep on adding 180. When you add 180 degree, you get 360. Then you keep on adding 180 degree, you will get the next number. So what will it be for pentagon? When I add pentagon, it has five sides. So 5 minus 2 into 180 degree. So that comes out to be 5 minus 2 is 3 into 180 degree. That comes out to be 540 degree. That's right. It's okay. Clear? So just remember this formula. N is minus 2 into 180 degree. By this, you are able to calculate the sum of whichever polygon which is given to you. All right. Okay. Now, this would be a question in the later half. I'll ask you that which figure has how many sides and what will be its angle. Before that, I'll give you a situation. I'll give you a figure and you have to tell me in which category does this figure fall. Okay, that's figure number A. Is it a simple curved? Is it? Yes. Is it a simple closed curve? Yes, it is closed. It is a polygon. Is it a polygon? Yes, it's made of all line segments and it's closed and it's simple. Yes, it is a polygon. And now you have to tell me which polygon is it? It is a convex or a concave? Think over it. Think of the diagonals. Are they all the diagonals coming inside? No. One diagonal is not coming inside. It's going outside. Can you see it here? Yes, this diagonal. That's why we call it a concave polygon. All right, moving on to the next one. It says the next figure is this one. Is it a closed? Yes. Is it simple closed? Is it a simple figure? Is it a polygon? Is it a polygon? Yes. Okay. Now it is a polygon. We all know it's made up of line segments. It's closed. It's simple. So yes, it is a polygon. How about which polygon it is? Is it a convex or a concave? It is a convex because all the diagonals are coming inside. Well done. Good. Okay, now you have to tell me what will be the measurement of x. This is a little easy question, but you may find it complicated when you don't know what exactly the value is. Great, great. Good going, Mohit. Well done. Okay, can you tell me the angles of measurement of x in the following? So this figure has an angle of 50 degree, 130 degree, 120 degree, and x. So if I say x plus 120 degree plus 130 degree plus 50 degree, it should be equal to what? It should be equal to what should be the total sum of a quadrilateral that we know? It should be 360 degree. Okay, Mohit, you got 60 as the answer. Let's see. All right, 360 minus 300, that comes out to be 60. Great. Moving on to the next one. You have to tell me what is an angle measurement for this figure. You have to tell me the angle measurement of x. And we don't know the measurement of y, right? So when we don't know two measurements, can we find it? No, we cannot. Why? Because it makes a problem to know the variable, two variables. Yes. So for this, what do I have to do? I need to give a value and look at the things very carefully. All right. How to proceed now? Can you see this? See, when you look at there, it is 180. This is 180 degree. This is already 90. So I have to calculate the next 90. For that, 180 minus 90, I'll get 90. See, a straight line is 180 degree. I already know 90. The next I can calculate by subtracting. So by this, I know that the value for the y is 90 degree. Now I think it's pretty easy to calculate the value of x. That means I know this value. This is 90 degree now. Right. So I know the sum, and the sum should be equal to 360 degree. So 360 should be equal to x plus 70 degree plus 60 degree plus 90 degree. So what's the value of x? Quickly tell me. What's the value of x? So the value of x is, yeah, what's the value of x? Calculate and tell me. Okay, so the value of x will be 140 degree. Clear? We got x because the external angle is 90. We know it's a plane surface. This should be 180 degree. So 180 minus 90, that comes out to be 90 degree. Great. Well done, Mohit. Moving on to the next one. Find the angles for this one. You have to use the angle property. You have to tell me what will be the angle of X. See, in this, we would say nothing is given to us. No, but we know the formula. See, we know they are all equidistant. They are equal in the sides. So that means we know their angles will also be equal. So what are the sides? How many, what figure it is? How many sides does it have? 1, 3, 4, 5. Five-sided figure, we call it a pentagon. We know how to calculate the sum. So what are the sum of 5 figures? We have already done that before. It is 520, right? Yeah, it's 540. I'm sorry. Yeah, it's 540. So when it is 540 degree, how we said it has to be calculated by n minus, what was it? Can you tell me? N minus what into 180 degree? 2. This was a sum, right? Yes, so 140, for calculating one angle, I need to know the value of X. It is X is equals to 540 degree divided by 5, because we have 5 angles and they are equidistant. Well done, Mohit. I'm very happy you're understanding it. So when I divide it, it's known as 108 degree. Let's see, have we got the right answer? Yes, we got the right answer. Well done. Okay, now this is a question that you need to solve it on your own and you have to give me the answer next time. Let's hope, are you able to do it or not? I'll give you the answer next time. This is a figure in which you need to calculate the value of angle X, angle Y, and angle Z. So you know what will be the value of X? It is already 90. That means here it will be 90 degree. How about this angle? Similar way you have to calculate this angle. Can you do that? It's a straight line, 180. I'll already know the angle 30. So what will this be? You can calculate. Now, after getting these two values of X and Z, how will you calculate the value of Y is the question. Think over it, give it an answer. If you know it, you can do it. Give me the answer in the chat box. I'll look at it later also, okay? Let's see, are you able to do it or not? And I'll give you the answer for this in the next class. I'm not telling the answer right now. Let's see, are you able to do it or not? All right, so what all we have done today, we have done introduction to a plane surface, a plane curve, what is a polygon, how do we classify the polygons, how do we differentiate actually the figure is a polygon or not, what is a diagonal, and what are the types, 4 types of polygons we have done today. Convex, concave, regular, and irregular. All right, that was great, Mohit. You already given me the answer. Okay, let's see the total answer is right or not. In the next class, I'll give it to you, okay? All right, thank you so much for being together. It was lovely teaching you all. Hope to see you in the next session of the quadrilaterals, and we can know more about what's quadrilateral and understand. Catch you all together next time. Before that, if you miss any update, don't do that. Please subscribe to the channel and press on the bell icon so that you get the notification beforehand. And even if you want to watch your favorite teacher teaching, give us a lecture, kindly look into it one day prior. So each and every day we make a list, we show what is coming on the update on the next day. So today you will able to see what is coming today until by the evening around or in the afternoon 4 or 5, you will get the schedule of what will we are teaching on the next day. Hope to see you all. It was best part teaching you all. All right, then take care. Bye-bye. Mohit, you will get it on, I'll update it on the YouTube when I am there on the next section. Okay, next class, when am I teaching, you will be there. You can look at the YouTube channel and please click on the bell icon so that next time you join on time with me. All right, take care everyone. Nice teaching you. It was a lovely time.